So 6.3 is all about finding the area of triangles. So there's going to be several cases we'll consider. We'll start with case 1, which is the classic case where you're trying to find the area of a triangle and you've been given the base and the height. So we all know this formula. It tells us that the area of a triangle is equal to 1/2 the base times the height. So if we look at the following example, we want to find the area of this triangle, and if we look at the diagram, we can see the base and the height. So all we need to do is plug that into the formula. So we're going to get 1/2 times 14 times 5. So the area is equal to 1/2 times 70. So the area is going to be equal to 70 divided by 2, which is 35 centimeters. And going to be centimeters squared. Okay, so let's look at the next case. So what we want to do to build up this case is to kind of think about what do we do if we don't know the height. So if we look at both of these triangles, we can say some things about the sine of theta. So we know that the sine of theta, we could also say something about the cosine and the tangent, but we're concerned about the sine. So we say the sine of theta is equal to h over a. Now, I want you to note that the sine of theta is equal to h over a for both of these triangles. It's clearer to see it in the one on the left, but I would like you to tell me why it's true for the one on the right, and I'll give you a bonus point on your next quiz. So go ahead and do that and write that on the back of a giraffe. Okay, so anyways, getting back to it, if we continue solving this for h, we get that a times the sine of theta is equal to h. So what can we do with this? If we go back to our classic formula for the area, 1/2 base times the height, we can substitute here for this h, the expression that we just found. So we are going to write the area equals 1/2 base. Instead of h, we're going to write a times the sine of theta. So what does that give us? It gives us the area is equal to 1/2 b times a sine of theta. And, typically you'll see this written as 1/2 ab sine of theta. So this gives us a way to compute the area of a triangle when all we know is two sides and the angle included between them. So that leads us to our next case, which is exactly what we just said. We are given two sides and the included angle, and now we can find the area. So the formula for that, as we just found, is going to be the area is equal to 1/2 a times b times the sine of theta, where a and b are the two sides, and theta is going to be the angle in between them. So let's look at the following example. Let's let 5 be a and 8 be b. And let's let this 35, let's let that be theta. So we just plug this into the formula. We know the area is going to be equal to 1/2 times a times b times the sine of 35 degrees. So if we clean this up, we'll get the area is equal to 1/2 times 40 times the sine of 35. And then finally 20 times the sine of 35. And that's going to be, drum roll please, sine of 35 times 20. So that's going to be 11.4715. And so that's approximately, 11.5 meters squared for our area. So remember, with area, we do square units. So this is going to be meters squared. Just like in the last example, we had, I believe, centimeters squared. So next, let's talk about case 3. So this one, I'm not going to derive the formula for this case, but we will talk about it. So in order to first talking about what we do when we're given a triangle and 3 sides, we need to talk about what a semi-perimeter is. So a semi-perimeter is defined as follows. We denote it with an S, and we say that S is equal to A plus B plus C over 2. So basically, we add up all the sides of the triangle, and then we divide them by 2, and we call that measurement the semi-perimeter. So the reason that's important is because in Heron's formula, we use, to find the area, we use this idea of a semi-perimeter. So I'll write down Heron's formula now. It says that the area of a triangle is equal to the square root of S times s minus a times s minus b times s minus c, where this s here is a semi-perimeter we just talked about, and a, b, and c are the three sides. So let's kind of highlight this formula a little bit, and then we'll do some examples with it. So Heron was a famous Greek mathematician, philosopher, just like Pythagoras we talked about earlier, and Euclid. And it was his formula that allows us to compute the area of a triangle when we're just given three sides this way. It's kind of neat, but the derivation is a bit complicated, so I won't go into it. So let's just do an example. We want to find the area of the given triangle, and we've been given three sides. So what I would suggest for these types of problems is starting out by finding the semi-perimeter and then putting that number into Heron's formula. So here we go. The semi-perimeter, recall, is a plus b plus c over 2. And if we substitute, let's see, let's let 6 be a, let's let 8 be b, and let's let 12 be c. We get 6 plus 8 plus 12 over 2 is going to equal 26 over 2, which is going to equal 13. Okay, so we have our semi-perimeter. And now I'm actually going to go ahead and put this into Heron's formula. So Heron's formula, once again, tells us that the area of a triangle is equal to the square root of s times s minus a times s minus b times s minus c, where s is the semi-perimeter and a, b, and c are the three sides. So we know the semi-perimeter is 13. And then we have the following. We have that a is 6. We have that b is 8. And we have that c is 12. And so now we're just going to simplify this. We're going to get 13 times 13 minus 6, which is 7. It's 13 minus 8, which is 5. And 13 minus 12, which is 1. So now we've got 13 times 35, which is going to be 455. And I'm just going to simplify that in my calculator. And I'm going to get, let's see, the square root of 455 is equal to 21.3307. And so that's approximately 21.3 and centimeters squared. So we were able to find the area of this triangle. We didn't know any of the angles. We don't necessarily know the height, but we do know three sides, and we use Heron's formula to take advantage of that to find the area. In the next video, you'll see more examples of how you can do this with more ambiguous cases. But these are the three main examples, or the three main cases that we'll discuss.